In this video, we solve the relationship mu r plus 1 is equal to pq into nr mu r minus 1 plus d over dp mu r. We can also find second moment about mean, third moment about mean, fourth moment about mean, and coefficient of skewness beta 1 and beta 2 for binomial distribution by using this relationship. So first we prove this relationship by definition of rth moment about mean. Mu r is equal to expected value of x minus expected value of x whole power r. As you know, expected value of x is the mean of the distribution. So the mean of binomial distribution is np. Expected value of x is equal to np. Put the value of expected value of x in this equation. We have expected value of x minus np whole power r. So by expanding this expectation, sum of x minus np whole power r, f of x is the probability density function for binomial distribution, which is ncx pxq power n minus x. So put the values in this equation. The range of random variable in binomial distribution is x from 0, 1 to so on n. So mu r is equal to x 0 to n x minus np whole power r, ncx px q is equal to 1 minus p. So we can write here 1 minus p whole power n minus x. This is first term and this is second term. So differentiate this equation with respect to p. D over dp mu r d over dp to this equation. So using product rule for derivatives, because we have two terms and these two terms are multiplying with each other. This is first term and this is second term. So the product rule is d over dx uv if one term is u and other is v. Write for first term as it is, take the derivative of second term, plus write second term as it is and take the derivative of first term. So we use this product rule for derivative in this equation. We apply product rule to take derivative. So d over dp mu r is equal to sum of x is equal to 0 to n. Take the derivative of first term. First of all, take the derivative of first term. So use here power rule, r x minus np r minus 1. Decrease the power minus 1 and multiply the unit of power. And then take the derivative of this term again, d over dp x minus n d over dp. And write the second term as it is, ncx px 1 minus p power n minus x plus. Now write the first term as it is. Take the derivative of second term. X minus np power r, write the first term as it is and take the ncx is the constant, take the outside, and then again derivative, take the derivative of this term. As you can see, these two terms have also product with each other. So we can apply product formula here again. So power rule apply here, px x p power x minus 1 and again the derivative of p which is 1, dp over dp which is 1. And write the second term as it is, 1 minus p n minus x plus. Write the first term as it is, px, and take the derivative of second term. Use the power formula, power rule, n minus x into 1 minus p, decrease the power by 1, n minus x minus 1. Again derivative of this term, one derivative 1 is 0 minus derivative of p dp over dp, which is 1. Now take minus nr, which is constant, out the summation sign. Summation x is equal to 0 to n x minus np power r minus 1 and ncx px 1 minus p power n minus x. This is equal to f of x plus x is equal to 0 to n x minus np power r ncx x p power x p power minus 1 1 minus p power n minus x minus ncx multiply ncx to both of these terms. So minus, this minus sign convert plus into minus, this minus sign convert this plus into minus, minus ncx. I use here ncx because it is the combination. In short form we write it as nx, but it is called ncx. P power x 1 minus p power n minus x. We split this term 1 minus p n minus x dot 1 minus p minus 1. When we add, as you know, when bases same powers are add. So I split this term and write it as 1 minus p power n minus x 1 minus p power 1 minus power minus 1. So here minus n r, sum of x is equal to 0 to n x minus np power r minus 1 f of x plus x ranges from 0 to n x minus np power r. This ncx p power x 1 minus p n minus x is equal to f of x, and this p minus 1 is equal to 1 over p. So we write it as x over p and ncx px 1 minus p power n minus x is equal to f of x. So it is this term is equal to f of x x over p minus here ncx px 1 minus p n minus x, it is equal to f of x n minus x over 1 minus p. We left with n minus x over 1 minus p. So as you know, f of x is equal to ncx px q power n minus x. Again minus nr, expected value of x minus np whole power r minus 1 plus sum of x minus np power r f of x. Take the common from this term, f of x take common. We left with x over p minus n minus x over 1 minus p. This term, write this term as it is and only solve this part. So we solve this part, p into 1 minus p, take the LCM, p cut this p and x multiply into 1 minus p. This minus sign cut 1 minus p, we have here p into n minus x. Again multiply x minus xp minus np minus minus plus xp, cut plus xp minus xp over p 1 minus p, write 1 minus p is equal to q. So write here pq. So I write it as 1 over pq, sum of x is equal to 0 to n x minus np power r x minus np power 1 f of x. And this term, when we take this term to the right side, it is equal to nr mu r minus 1 plus d over dp mu r. So 1 over pq, x is equal to 0 to n x minus np power r plus 1 f of x. I write this term as this is equal to expected value of x minus np power r plus 1. because as you know expectation is equal to the sum of this term multiplied by PDF. So as you know this is the PDF and this is the sum of this term. It is equal to expectation of x minus np power r plus 1, and multiply by cross multiplication. PQ goes to the right side, PQ into nr mu r minus 1 plus d over dp mu r. So it is equal to mu r plus 1. Mu r plus 1 into PQ nr mu r minus 1 plus d over dp mu r. So we prove this relationship mu r plus 1 is equal to PQ into nr mu r minus 1 plus d over dp mu r. So the first moment about mean is 0. As you know, the first moment about mean is represented by mu1 and it is equal to mu1 prime minus mu1 prime. The first raw moment minus first raw moment, so it is equal to 0. So from the above relationship, we find our task is from this relationship we find the second, third and fourth moment about mean. So put the value of r in the above relationship. Mu2 is equal to PQ n or when put here 1, it is 1 n mu naught plus d over dp mu 1. So mu naught is equal to 1 and mu 1, which is the first moment about mean, is 0. So put here 0 and we left mu 2 with npq. Putting r is equal to 2 in this relationship, mu 3 is equal to pq 2n mu 1 plus d over dp mu 2, d over dp mu 2. So mu 3 is equal to pq 2n mu 1 plus d over dp mu 2 is equal to npq. Mu 1 is equal to 0 and mu 2 is equal to npq. So mu 3 is equal to pq into 2n0 plus d over dp np 1 minus p. And take outside d over dp p minus p square. PQ 2n0 is equal to 0, 0 plus n 1 minus take the p common outside. So we have 1 minus 2p. So np n outside npq is equal to 1 minus 2p. Here apply the derivative of dp. When apply derivative, as you know, derivative for minus term is derivative of first term, sign remains same, minus, and derivative of second term. dp over dp cancel out. Here we left with 1 minus. Apply here power rule. Power is multiply with the term 2p and subtract or decrease power by 1. 2 minus 1, 1. So we left here 2p by using power rule. So npq into 1 minus 2p, which is the third moment about mean. Putting r is equal to 3. In this relationship, r is equal to 3. Mu 4 pq 3 n mu 3 minus 1 mu 2 plus d over dp mu 3. Mu 2 is equal to npq, mu 3 is equal to npq into 1 minus 2p. So mu 4 is equal to pq 3n mu 2 npq plus d over dp. Write n mu 3 np. We write q as 1 minus p, 1 minus p, 1 minus 2p. Mu 3 is equal to npq 1 minus 2p. We write q as 1 minus p. So next pq 3n npq plus n d over dp. Multiplying these two brackets, when we multiply it with 1, 1 multiply 1, 1 multiply minus 2p, it is minus 2p. Minus p multiply with 1 minus p multiply with minus 2p, minus minus plus 2p square. Here again multiply p inside the whole bracket, p minus 3p square minus 2p minus p is equal to minus 3p. So minus 3p square plus 2p power 3. Apply the derivative separate to each term. dp over dp minus 3 d over dp p square plus 2 d over dp p power 3. And dp over dp is equal to 1 minus 3 multiplied by with 2 6 p plus 3 multiplied by 2 6 and p power 3 minus 1 p square. 3 n square p square q square. 3 n square p square q square plus 1 minus 6p minus 6p square. So 1 minus, take this minus 6p common outside, we left with 1 minus p. So npq 1 minus, we left with 1 minus 6pq, because 1 minus p is equal to q, we left here with q 1 minus 6pq. So our answer is 3 n square p square q square plus npq into 1 minus 6pq. This is the fourth moment about mean, because this pq multiply both these terms. So here when you multiply pq, this term we have 3 n square p square q square, and this pq multiply also with this term npq. So 1 minus takes 6p common, 1 minus 6p, when you take minus 6p common, we left here plus 1, because we take minus 6p common. 1 minus this plus sign convert into minus, because we take minus 6p common, we left with p. 1 minus p is equal to q, so this is q. So we prove mu 4 is equal to 3 n square p square q square plus npq into 1 minus 6pq. Now we prove coefficient of skewness beta 1 and beta 2. Beta 1 is equal to mu 3 square over mu 2 whole power 3. So as you know, mu 2 is equal to npq and mu 3 is equal to npq into 1 minus 2p. So put the value of mu 3 npq into 1 minus 2p whole square over mu 2 is equal to npq power 3. So we write 3 power 3 as by parts, n square p square q square into npq, and by squaring this n square p square q square into 1 minus 2p whole square. Cut this term with this term, we left beta 1 into 1 minus 2p power square over npq. We can write it as beta 1 1 minus p whole square npq. Beta 1 minus p, we write 1 minus p as q minus p whole square over npq. So we prove beta 1 is equal to q minus p square over npq. Now we solve beta 2. Beta 2 is equal to mu 4 over mu 2 square. Mu 2 is equal to npq and mu 4 is equal to 3 n square p square q square plus npq into 1 minus 6pq, as we already proved this. So put these values of mu 4 over mu 2 square. We divide by parts these two terms, 3 n square p square q square over n square p square q square plus sign, and here is not 3, this is npq. We write 3 as this is the error, here is npq because this is npq. So correct this npq. Here in second term it is in correct form, npq into 1 minus 6pq over npq square. Cut this square with this. So we left here 3 plus 1 minus 6pq over npq. Here this is the proof of beta 2. If you want to see more videos about probability distribution, I already solved the discrete uniform distribution, Bernoulli distribution, and the binomial distribution. And in the recent upcoming 1 month, I also solved the discrete and continuous distribution. So keep watching my channel Statisticians Club and also subscribe the channel Statisticians Club to watch more videos about probability and probability distribution. Thanks for watching.